Sofia Perez Paredes, and today I will be talking about electrical potentials and currents. So the first current that I'll be talking about is the resting membrane potential. So the resting membrane potential is maintained by the sodium positive slash potassium positive pump, which pumps 3 sodium ions out of the cell and 2 potassium ions out of the cell, creating an electrical chemical gradient. And then it also leaks positive potassium channels, allowing the potassium ions to move out of the cell, contributing to the negative charge inside. So you can see here and then also here. And then the next one will be the local potential. So this is a mechanically gated ion channel that allows ions to flow across the membrane. So as you see here, they are flowing across the cell membrane. And then the magnitude of the local potential depends on the strength of the stimulus and decreases with distance from the stimulus. The last one will be the action potential. So there is depolarization, which is right here. And then if the threshold is reached, voltage gated Na positive channels open, allowing Na positive ions to rush into the cell, depolarizing the membrane. And then the repolarization is the Na positive channels close and voltage gated K positive channels open, allowing positive potassium ions to leave the cell, repolarizing the membrane. And then it'll be the hydropolarization, which is the potassium positive channels remain open briefly, causing the membrane potential to become more negative than the resting potential before returning to the resting potential. And then the last one will be the recovery period, which during this period, the membrane is less responsive to further stimulation. And it also ensures that action potentials is in one direction. So thank you so much for watching. And then just to sum everything up, we talked about the resting potential, which maintained by the sodium and the potassium pump, and it leaks potassium channels around -70 MV. And then there's the local potential, which are small graded changes in the membrane potential in the responsive of stimuli. And then the action potential, which is rapid, all or nothing change in membrane potential involving depolarization, repolarization, and hyperpolarization. Thank you so much.